Support handout number 7. So in problem 1, we've got a period given to us for a function in this form, y equals sine bx. We're just trying to figure out the value of b. Well, we do have a little formula that we learned that tells us that b is simply equal to 2 pi divided by the period. That's the relationship between b and the period for the sine function. So I just need to apply that in all of these problems. The first one I would have 2 pi divided by pi, and so the b value would be equal to 2. And then I would have 2 pi divided by 6. That's going to reduce to pi over 3 as the final value of b. Here, let's see, I'll have 2 pi divided by 3 pi over 4. Of course, dividing by 3 pi over 4 is the same as multiplying by the reciprocal, multiplying by 4 over 3 pi. So I think I'll write it that way. Let's see, the pi's cancel, and it looks like I end up here with 8 on the top and 3 on the bottom. So 8/3 is the value of b. I'll take a similar approach for this last one. It's 2 pi divided by 2/7. I'll do times the reciprocal times 7/2. Here it's going to be the 2's that cancel. The b value this time would be 7 pi. Problem number 2 is a thinking exercise. If I was able to walk 1/4 of a mile every minute, assuming the same rate, how many minutes would it take me to walk 1 whole mile? So I get 1/4 of a mile in that first minute. Let's see, then I'd be up to 2/4 after 2 minutes, 3/4 after 3 minutes, and then 4/4. Well, 4/4, 4/4, that's 1 mile. So that took me 4 minutes to get up to that point. Letter B, what if my car used 2 gallons of gas every hour? Well, how many hours would it take to use up 1 gallon of gas? Obviously less than an hour. And again, assuming the same rate, if 2 gallons takes a whole hour, then 1 gallon, of course, would take half an hour. And letter C, let's say I am packaging something and I can put 0.2 pounds in each container. So how many containers would I need if I'm packing up 1 whole pound? Well, obviously more than just one. I only get 0.2 pounds in each container. I could work this with the decimal. It might be easier, though, to change it to a fraction. 0.2 is just 2/10, which reduces to 1/5. So I get 1/5 of a pound in the first container, and then 2/5, 3/5, 4/5, 5/5. It would take me 5 containers to fit in that whole pound. These are all called rates with the per, and you can see that switching the order of the units can easily be accomplished by just taking the reciprocal of the original number. The reciprocal of 1/4 is 4, of 2 is 1/2, and of 0.2 or 1/5 is 5. Problem number 3, we want to take this function f of x equals x cubed minus 4x and get it in the calculator. So I'll go to the y equals and put in x cubed and then minus 4x. We want that zoom standard window. That's zoom 6, which shows us 10 in every direction. And so there's our graph. Now we've got a new function, g of x, which is formed by taking the old function and simply adding 3 to it. So this is very easy. Just take x cubed minus 4x and tack on a plus 3. So here's g of x. We want to add that to the picture and see how the graph changes. So I'll go back to y equals, go to the second line. I'll do x cubed and minus 4x plus 3. The second graph will come up in red. Let me hit graph. So what has happened here? Hopefully what you can see is that it looks like somebody just took the blue picture and simply moved it. In this case, moved it directly upward. So I can see here, for example, that the top spot here used to be at 3, whereas now it's at 6. Here, the bottom spot of this little valley was at -3. Now it's up here at 0. Each point looks like it's been moved up exactly 3 spaces. Even this one here at 0, 0, now it's up here at 0, 3. We say the graph shifted vertically by 3 units in an upward direction.